Hello, my name is Michael, and I'm here to talk about consumerization of quantum technology. So, the first question that often comes up is what even is quantum technology and what is quantum computation? Well, to start explaining, quantum computation uses qubits instead of bits. Bits in a classical computer, which you are using to watch this video right now, are always 1 or 0, on or off. Qubits can be written down as being in bit 1, bit 0, or qubit 1 and 0. This behavior is known as superposition. What is superposition? Well, superposition is the ability of a particle, an electron in this case, to occupy 2 points in space at the same time. To give a little bit more information on it, atoms in a compound, oxygen, O2 for example, share electrons. A shared electron in their covalent bonds is in superposition as it has to be in both atoms of oxygen at the same time. Otherwise, the atoms will act as individual. They would want to react with other things, or other atoms. And we can further prove that the electrons are in superposition as electrons have to be in movement around the atom in an orbit, or to some models, in a statistical probability cloud around the nucleus of the atom. So the next question that can sometimes comes up is why does quantum computation even matter? Well, first we got to talk about what does a qubit even do other than having that special state. Well, to start is bits are sequential, meaning if you were to put them in a metaphorical maze, a electron or bit would check each path until it comes across a dead end or the exit, one by one. Qubits, however, work in parallel. It would split up to check every possible path until it finds an exit or a dead end. If it finds a dead end, the split, quote unquote, goes back to the host or the main electron. Which this means also quantum computation is exponential instead of multiplicative or additive. I'm actually not entirely sure which word to use there. A handful of qubits currently can can outpace current classical processors. Since it is exponential, it would only take a few qubits to catch up if they have a similar process cycle. So some uses for quantum computers can be drug development, data crunching, and machine learning, which we will talk about later in the presentation. One thing I do want to touch on, other than just quantum computation, is quantum networks and what they could mean for us as a people and for consumers. Mainly, it would be data transmission, obviously, and this uses another quantum property called quantum entanglement. Quantum entanglement allows for instantaneous data transmission. Researchers have used quantum entanglement to transfer data from one microchip to another. And another team of researchers were also able to transfer the data up to 27 miles away, and I think even further in some recent experiments. And this was done in a quantum internet that they had set up for these experiments. So, to continue on the possibilities of the consumerized quantum technology, first we have classical quantum hybrid computers, which this is just a possibility that I've thought of, and haven't really found any articles talking about this, as it is still quite the ways away, 10 years at the least, 20 or 30 at the most. Classical computers could use an extension card for qubits. So you could have your regular computer and then have a firmware patch that would allow you to slot in an extension card like a graphics card to allow for some qubits or a quantum processor to be added to your system. A pure hybrid would have native qubits and bits on the processor. So you'd have the regular bits for general workload like watching videos or typing up an essay. And then if you were also working with heavy data like a scientist or maybe in the future if games were to use it, you could have those qubits there to crunch through extensive data and physical processes or physics simulations. So a less than 5 milliseconds latency global network could become a reality, and if not even less, by using quantum entanglement like the researchers had used. As this would have a huge impact on how we communicate and work with data as a whole. If we were to have local networks that have like zero latency, absolutely none, like on the microseconds instead of milliseconds or even less, that would allow supercomputers to take up far less space as they don't have to run wires everywhere. You could theoretically set up chips to communicate wirelessly just by having a physical component that would allow for the entanglement of electrons or protons or photons or whatever particle that is most efficient at the time. Another really big use is artificial intelligence. Qubits' innate parallel nature could allow a neural network to work on a new level of efficiency. Instead of trying each possible connection one by one, we could have programs that would be able to try several, like how our own brains work, which is where the neural network idea even came from, was mimicking our own brains. If we were to be able to accomplish this, we could, in theory, achieve artificial intelligence on the level of human intelligence, if not more. And one that I really like is a full dive virtual reality, as quantum computation could be a gateway to simulating our five senses, along with the use of Neuralink or some new invention further down the road. Neuralink is a brain-computer interface which has made recent significant headway. You probably heard about it from the news, as they recently have been able to have a monkey play Pong without using a controller, just by looking at a screen and thinking. In the future, we could have a full dive virtual reality that can simulate our senses, that could help with some mental disabilities or mental illnesses, such like some kind of treatment that you might be able to go into a world with a psychologist to be able to sit down and talk to you in a completely different setting than you could normally. So to continue on the possibilities of it, one really big possibility is also data crunching, fluid simulations, artificial intelligence again, aircraft design, like a whole host of things, like simulating our universe, for instance, or our solar system, or like several, like hundreds of things, if not more, particle physics interactions. The artificial intelligence, like as I've already hit on, is pretty much a revolution waiting to happen. An AI that with similar human knowledge or capability could become a really big game changer. And moving on to further talk about drug development. Drug development can be sped up drastically by using quantum computers for medicine synthesization by using simulations on a larger scale, which when in turn allow for faster responses to pandemic situations, as we have been dealing one for the last year and a half almost, or yeah, about a year and a half now. And also, this could also give rise to better medical care in general by being able to use a quantum computer to simulate your body and like how it works and what could be going wrong and figure out what the source of it is. Uh, and something that could come of it by using quantum computers on a small scale could be an assistive neurological implant. Uh, like how Neuralink works, it is just a brain computer interface. So you can use your brain to talk to a computer. But what if we were to reverse that or invert it, where it is a computer assisting the brain instead, where a computer talks to the brain? So, say if you have a brain injury and it's never going to heal, instead of losing the process of that brain, of that part of the brain, you could use an implant to assist with the recovery of it. So, say if your motor cortex has been damaged, you could use a neurological implant in a small quantum computer to take place of that until either healing has been done or to accelerate the healing. And this is all like more fantasy and theoretical, but it is still a possibility. So, the thing that I really want to see the most out of quantum technology, well, is highly efficient and extremely fast neural networks. I I have a dream of working with AI and creating AI with similar to human efficiency, where we could talk to it in our own language, well, as if it was a human as well. And I don't mean like you could say, "Hey Google," and end up searching Google or opening an app. So, my final remarks as the sources page comes up is that most of this was more fantastical thinking and looking into the future. However, most of it, if not all of what I've proposed here and talked about here, is possible within what we can see and witness today, with how quantum computers are extremely fast and having extremely low latency networks using quantum entanglement. And even Neuralink being able to have our brain interact directly with computer. It most of it, if not all of it, is just gonna take some time. And it makes me excited for the future to see where we're gonna go and what we'll be able to do. Thank you.